Welcome back to Boring Science for Sleep. If you're here for the first time, I'm glad you found us. This is a place where science moves slowly, where the facts are soft enough to rest on. If you'd like to hear more quiet journeys like this, don't forget to subscribe before you drift off. And tell me, what time is it where you are right now? And what does the night look like outside your window? Now, close your eyes, if you wish. Let the room grow still. Let your breath find its slow rhythm. Picture a mountain, its dark silhouette holding the stars behind it. It stands so still, its slopes dressed in forests and quiet stones. But deep inside, beneath the roots of the mountain, beneath the soil and rock, there is movement, a restless warmth, stone that is not solid, flowing in silence. It has been there for millions of years. It rises and sinks, pressing, searching, waiting for a path to the surface. One day, that quiet mountain will change. It will open, breathe fire into the sky, and shape the land in a way no human hand ever could. But how does such a thing begin? How does the Earth decide to grow a volcano? Let's take a slow walk down into the heart of the planet and see where fire is born. If you could sink slowly into the ground beneath your feet, past the soil that smells of rain, past the roots that grip like gentle fingers, past the stones worn smooth by time, you would feel it, a warmth that is not sunlight, a heat that does not fade with the seasons, a slow, steady fire kept in the heart of the earth. This is where volcanoes begin, not on the mountain's peak, not in the rivers of red lava you've seen in photographs, but here, in the unseen depths, where rock itself flows like honey, and the dark is total. We tend to think of rock as solid, as unmovable. We see cliffs that have stood for centuries, boulders unmoved by storms, and we assume permanence. But far below, deep enough that no human can dig, the rules of stone begin to change. Here, the pressure is immense, enough to crush metal, enough to squeeze the spaces between atoms. The temperature is searing, hotter than the surface of some planets. In such conditions, stone softens, not like melting ice, but like wax under a steady flame. It becomes something between liquid and solid, able to flow slowly, to rise and fall in currents, like a thick, glowing tide. This flowing stone has a name, magma. It is born from two forces working together, heat from within the earth and the shifting plates of the crust above it. The heat is ancient. Some of it is left over from the Earth's own formation, the energy of countless impacts, of a young planet still finding its shape. Some comes from the slow decay of radioactive elements, locked inside the planet's body, uranium, thorium, potassium, releasing energy not in sudden bursts, but in whispers that add up over millions of years. Together, these sources keep the mantle, the thick layer beneath the crust, in constant motion. It is not boiling, not raging, but endlessly turning, like a giant, slow breath. The surface, where we walk and live, is the thinnest layer of all. Compared to the mantle beneath, it is like the shell of an egg, strong enough to hold its shape, but fragile if cracked. Beneath that shell, magma pools and swells. It pushes gently most of the time, with nowhere to go, but it is always searching, always listening for weakness. A thin seam in the crust, a fracture formed by the drifting of continents, a spot where one tectonic plate slides beneath another, dragging rock down to melt, making room for molten rock to rise. If you could stand in that hidden place, you would hear nothing. No roar, no hiss. Just the low, heavy silence of stone under pressure. Yet, if you waited long enough, you would see the slow work of heat. Bubbles forming in the magma, trapped gases stretching and twisting their prison of molten rock, crystals growing and dissolving, as minerals rearrange themselves in the heat. Every movement measured in years, every shift the beginning of a story that may take centuries to reach the surface. Sometimes, magma never makes that journey. It cools slowly underground, becoming solid again, granite, gabbro, diorite, hidden away until erosion, or the patient work of rivers, brings it to light. Other times, the pressure builds just right. A chamber of magma, deep and wide, fills until the weight of the rock above can no longer hold it back. It finds a crack. It follows the path of least resistance, and it begins to rise. The rise is not like a flood. It is not quick. Even when magma is on the move, it can take weeks, months, or even years to travel from its source to the surface. The rock around it pushes back. The crust resists. Sometimes the magma cools before it reaches the air, forming veins of new rock within the old. But sometimes it comes all the way. When it does, the world above changes. Not always in an instant, but inevitably. That heat you cannot see, that warmth buried miles beneath you, is not dangerous by itself. It is patient. It can wait longer than civilizations last, but it is also persistent. It will find a way upward, sooner or later. And when it does, a mountain will grow, not from stone brought in from elsewhere, but from the earth's own deep heart, spilled out and piled high. So the next time you see a volcano, whether sleeping in the sun or smoking gently in the dawn, to remember that it began here, in the dark, in the heat you will never feel directly. A quiet place, working slowly, shaping the land above without hurry. Volcanoes do not start with explosions. They start with stillness, with stone that remembers how to move, with the earth's own warmth, reaching upward through the quiet. If you have ever seen honey warm in the sun, you know how it moves, slow, deliberate, its surface folding over itself in golden curves. Magma moves like that. Not quickly, not with the rush of water or the scatter of sand, but with the patience of something that has nowhere to be, and all the time in the world to get there. But magma is not honey. It is stone, stone so hot it can no longer hold its shape, stone softened until it flows. Magma is born in places of quiet violence. Deep in the mantle, the pressure and temperature create a fragile balance, solid rock held just below the melting point. Then something shifts. Perhaps a plate drifts apart, opening space in the crust above, and allowing the mantle to rise, losing pressure as it goes. Or perhaps a plate dives beneath another, carrying with it oceanic crust soaked with water, which lowers the melting point of the rock around it. Either way, part of the mantle begins to melt, and magma is born. When it first forms, magma is thick and heavy, but lighter than the solid rock above it. It rises because of this difference, just as warm air drifts upward through cooler air. It doesn't race, it drifts, finding cracks, following faults, slipping into spaces left by shifting stone. Some of these paths are wide, allowing magma to move more freely. Others are narrow, squeezing it until it slows, cooling along the way. The temperature of magma is staggering, anywhere from 650 to over 1,200 degrees Celsius. But it is not the same everywhere. Some magmas are runny, able to travel long distances without hardening. Others are thick, barely able to move before they begin to solidify. Magma carries more than just heat. It carries gases, water vapor, carbon dioxide, sulfur dioxide, dissolved and trapped within it by the crushing pressure underground. As magma rises, that pressure eases, and the gases begin to escape, forming bubbles. These bubbles change everything. They make magma more buoyant, helping it rise faster. But they also increase its potential for violence, because if the bubbles cannot escape before reaching the surface, they will burst all at once, the beginning of an eruption. Sometimes magma gathers underground in large pools called magma chambers. These are not hollow caverns filled with glowing red liquid, as we might imagine from movies. They are more like sponges soaked with molten rock, a complex network of molten crystal surrounded by solid rock that holds the heat in. A magma chamber can feed a volcano for decades, centuries, or even longer. It can swell slowly, each pulse of magma from deeper in the earth, adding pressure to the chamber walls. If the rock around it is strong, it may hold that pressure for years. If it is weak, a fracture will open, and magma will find a path upward. When magma moves, it doesn't always move directly toward the surface. It can spread sideways through the crust, forming horizontal sheets called sills. It can rise vertically, creating dikes that cut through older rock like blades. It can pause for years in one place, cooling just enough to become thick and pasty, before moving again. Every journey is unique, shaped by the rock it must pass through. Some magmas travel quickly, reaching the surface in months. Others may take thousands of years, advancing only a few meters each year. And sometimes, the journey ends before the surface is reached, leaving behind solidified bodies of rock that will never erupt. If you could see magma in motion underground, it would not be the roaring, rushing river of fiction. It would be a slow, glowing tide, rolling over itself in near silence. Occasionally, a sharp sound would break the stillness, rock fracturing as the magma forces it apart. But most of the time, it is a quiet migration, more like the drift of continents than the crash of waves. Eventually, if the path holds, magma approaches the surface. Here, the pressure drops sharply. The gases trapped inside it expand, sometimes 100-fold. If the magma is runny, those gases can escape easily, and the eruption that follows will be gentle, a slow outpouring of lava. If the magma is thick, the gases cannot escape so easily. Pressure builds until the rock above shatters, releasing the magma in an explosive eruption. The story of magma is not just one of destruction, it is also one of creation. Every time magma reaches the surface and cools, it adds new rock to the crust. It builds mountains, extends coastlines, creates islands where there was only sea. Over time, the rocks formed from ancient eruptions will be broken down by wind and rain, turning into soil. Plants will grow in that soil, animals will follow, and a new landscape will emerge, all because stone once flowed beneath the quiet. When you look at a volcano, you are not just looking at a mountain. You are looking at the end of a journey, one that began deep underground, in heat and darkness, in the slow movement of stone. That mountain is the surface memory of magma's long, patient climb. Imagine the earth as an egg, not the smooth kind you find in a nest, but one whose shell is already mapped with faint, winding lines, hairline fractures stretching across its surface. That shell is the crust, and those lines are not accidents. They are the boundaries between the great slabs of rock we call tectonic plates. The crust is not a single, unbroken piece. It is a mosaic, a puzzle made of plates that drift slowly across the mantle. We don't feel them move in our daily lives. They shift only a few centimeters each year, about as fast as your fingernails grow. Yet, over millions of years, that slow motion shapes continents, raises mountains, and, of course, creates the openings that volcanoes need. These plates float on the mantle's slow currents, driven by the same heat that creates magma. Where two plates meet, something always happens. Sometimes they pull apart, sometimes they collide, and sometimes they slide past one another, grinding like enormous slow-moving gears. Each kind of meeting leaves its own mark on the earth, and some create perfect paths for magma to rise. When plates pull apart, As they do along mid-ocean ridges, they leave behind a gap, an opening in the shell. The mantle below rises to fill it, and as it does, pressure drops and rock melts. Here, magma doesn't have to fight its way through. The door is already open. This is why much of the world's volcanic activity happens far from land, along invisible seams beneath the sea. At places like the Mid-Atlantic Ridge, lava seeps up almost constantly, cooling instantly in the cold ocean water, building new seafloor grain by grain. When plates collide, the story changes. One plate is forced beneath the other in a process called subduction. As the sinking plate descends into the mantle, it carries with it water trapped in minerals and sediments. That water is released as the plate sinks deeper, and it changes the chemistry of the surrounding rock, lowering its melting point. The result? Magma forms above the descending plate and begins to rise through the crust. This is how the volcanoes of the Pacific Ring of Fire are born. Chains of peaks that arc around the ocean's edge, each one fed by the quiet work of subduction deep below. There is a third path. Hotspots, places where plumes of unusually hot mantle rise straight up, melting rock at the base of the crust. Unlike other volcanoes, the hotspot volcanoes are not always tied to plate boundaries. They can appear in the middle of a plate, far from the edges. The Hawaiian Islands are a perfect example. Each island is a snapshot in time, formed as the Pacific Plate drifted slowly over a fixed hotspot. New volcanoes rise, older ones drift away and go quiet, and the chain lengthens with every passing millennium. From far above, the surface of the Earth looks calm. Mountains stand steady, plains stretch without interruption, oceans shimmer under the sunday. But beneath that calm, the plates are always moving, pressing and pulling against each other. Sometimes the movement is gentle, folding rock into ridges and valleys. Sometimes it is sudden, releasing earthquakes that shake the land. And sometimes it creates cracks, narrow openings that reach deep enough for magma to notice. When a crack forms, it doesn't immediately glow with molten rock. Magma is patient. It waits for the right conditions, enough pressure from below, enough weakness above. It may test the path, rising a little before cooling back into solid stone. But if the crack stays open, and if the magma beneath it continues to swell, the journey will continue. Step by step, it will rise toward the surface. It's strange to think of volcanoes as products of brokenness, of cracks, faults, and fractures in the Earth's shell. We imagine creation as something built from strength, but here, it's the opposite. It is the gaps, the openings, that allow something new to emerge. In this way, the crust is not just the ground we walk on. It is a living puzzle, its pieces in constant, silent motion. And every time those pieces shift, they write a new chapter in the story of magma. Some chapters are long and uneventful, filled with quiet drift. Others are brief and dramatic, ending in an eruption that changes the land in a single day. But all of them start the same way, with a crack in the shell and the slow, unseen decision of magma to rise. When we look at a volcano, we see the surface result, the mountain, the crater, the trail of past lava flows. What we cannot see is the network of openings below it, the pathways carved by the shifting plates of the Earth. Without those movements, without those cracks, volcanoes would have no way to breathe. Next time you stand on solid ground, remember, it is not as solid as it seems. It is floating, drifting, changing shape beneath your feet. And somewhere, far below, a stream of molten stone may be watching and waiting for the moment when the shell opens and the journey can begin. A volcano is never built in a day. It does not appear suddenly on an empty horizon, whole and finished. It grows slowly, layer by layer, eruption by eruption, each moment of fire followed by long stretches of stillness. What you see as a mountain is not a single event. It is the memory of many, stacked upon one another. When magma reaches the surface, it is no longer magma. It becomes lava, bright molten rock flowing into the open air. Its journey changes here. No longer squeezed in darkness, it meets the chill of the atmosphere, the touch of wind, the hiss of rain. Every lava flow leaves behind a hardened ribbon of stone. Some flows creep gently down the slopes, cooling slowly, forming thick, dark layers of basalt. Others are more violent, breaking into jagged fragments that pile up in rough heaps. Over time, these flows stack upon one another, like pages in a book you can't read all at once. Not every eruption is the same. Sometimes, the magma is runny, its gases able to escape freely. This kind of eruption builds gently sloping shield volcanoes, where lava spreads far and wide before it cools. Other times, the magma is thick and sticky, trapping gases until they burst free in sudden explosions. Ash and pumice rain down from the sky, settling in soft, pale blankets that later harden into stone. These explosive eruptions build steep-sided stratovolcanoes, layered mountains of lava, ash, and rock, each layer telling a different part of the story. If you could slice a volcano in half, its inside would look like a cake made by a restless baker, dark layers of cooled lava alternating with pale bands of ash, some smooth and even, others broken and chaotic. Each layer is a chapter in the mountain's history. Some are only a few centimeters thick, the result of small, quiet eruptions. Others are meters deep, left by cataclysms that reshape the land for kilometers around. Between eruptions, time does its quiet work. Rain falls. Streams cut into the slopes, carrying away loose fragments. Seeds take root in the fresh soil that forms from weathered volcanic rock. Plants grow. Animals arrive. When the next eruption comes, it buries all of this beneath a new layer of stone and ash, preserving it, sealing it away like a pressed flower in a book. Sometimes, centuries later, those buried layers are revealed again, by erosion or by human hands, offering a glimpse into the landscape of a distant past. Some eruptions change the shape of the mountain dramatically. A powerful explosion can blow away the summit, leaving behind a crater or a wide, circular caldera. These empty spaces may later fill with rainwater, becoming deep volcanic lakes that reflect the sky as if holding it in their arms. Other eruptions add new peaks or ridges, as lava forces its way out through side vents, building smaller cones on the flanks of the main volcano. Over thousands of years, a single volcano can become a cluster of peaks, each with its own layers and stories. From the outside, we see only the mountain in its current form. We forget that it is still being written, that somewhere beneath the surface, magma may already be preparing the next chapter. Even in long periods of silence, the volcano is not finished. It is simply resting, waiting for the conditions to align again. Some volcanoes have grown for millions of years. Their bases sink into the earth, built from countless layers so heavy that they press the crust downward. Others are young, small cones still finding their place in the landscape. In either case, their growth is not steady. It comes in bursts, sometimes centuries apart, sometimes within a single human lifetime. That unpredictability is part of their nature. They are shaped by both patience and sudden change. In the end, a volcano's shape is the sum of every eruption it has survived. The gentle flows, the violent blasts, the quiet rains in between, all leave their mark. To stand on its slopes is to stand on time itself, solidified and stacked beneath your feet. Each stone you touch was once liquid fire, each patch of soil once born from ash. When you look at a volcano in the soft light of evening, its slopes painted gold by the setting sun, you are seeing not just a mountain, but the slow, layered memory of fire. It has been built in moments of chaos and in centuries of calm. It holds in its body the story of the Earth's deep heat, carried upward, cooled into form, and left to rest until the next layer is ready to be added. Volcanoes rarely erupt without warning. They are living mountains, and like all living things, they breathe, shift, and murmur before they act. If you listen closely, and if you know what to listen for, you can hear the subtle signs that something deep within is stirring. It begins far below, in the dark chambers where magma waits. For months, even years, it may sit quietly, its heat slowly softening the rock around it. But when conditions change, when pressure builds, when more molten rock rises from the mantle, the chamber begins to swell. The ground above it feels this change first. It may lift, just slightly, a few millimeters, barely enough for a human to notice. But scientists, with their sensitive instruments, record this rise like a heartbeat quickening. As magma moves upward, it forces gases out of solution, just as bubbles rise in a bottle when you open the cap. These gases, water vapor, carbon dioxide, sulfur dioxide, push and hiss through cracks in the rock. Sometimes they escape at the surface, through steaming vents or fumaroles. The smell of sulfur, sharp and metallic, becomes stronger in the air. This is the volcano exhaling, testing the pathways, checking the exits. The movement of magma is rarely silent. It grinds against the walls of its conduits, cracking and shifting the rock above. This produces small earthquakes, many too faint to be felt by people, but easily caught by seismometers. At first, the quakes come sporadically, like distant footsteps. Then, as the pressure builds, they become more frequent, forming swarms that ripple beneath the surface. Each one is a whisper from the deep. I am moving. In some volcanoes, the change is visible in the land itself. Hillsides develop new cracks. The shape of the crater subtly shifts. Snow and ice near the summit melt faster than usual, as heat seeps upward through the rock. Streams running from the mountain may grow warmer. Minerals carried in the heated water can stain the rocks red, orange, or white, painting the slopes with quiet warnings. Animals sometimes sense these changes before humans do. Birds leave their nesting grounds. Deer and goats move to lower elevations. Even insects disappear from the higher slopes. It is as if the entire ecosystem knows the mountain is about to speak. For people living nearby, some signs are more immediate. A constant rumble, like distant thunder that never fades. Ash drifting from vents near the summit, even on calm days. Small rockfalls on the steep upper slopes. These are the moments when those who watch volcanoes closely, scientists, rangers, villagers, begin to prepare. But the breath before fire is not always short. A volcano can tease for months, even years, sending signals that seem to lead toward an eruption, only to settle back into silence. This is part of what makes them so mysterious. Their timing belongs to the deep earth, not to human schedules. In some cases, the final hours before an eruption are marked by a rush of changes. Gas emissions spike, earthquakes cluster tightly near the summit, and the ground may lift faster, centimeters in a single day. If the magma reaches just beneath the surface, the heat alone can turn groundwater to steam, causing sudden sharp explosions called phreatic blasts, bursts of steam and ash that are like the volcano clearing its throat before the true eruption begins. For those who study volcanoes, watching these signs is both a science and an art. It is not just about reading numbers from instruments, but about understanding the personality of a mountain. Every volcano behaves differently. Some are loud, sending clear signals long in advance. Others are quiet, hiding their intentions until the last possible moment. From the outside, it can feel strange to think of rock and fire as having a breath. But if you stand near a volcano, in the days before it erupts, you can sense it. The mountain feels alive, There is a tension in the air, a hum in the ground, as if the entire structure is gathering itself for something inevitable. And then, when the moment finally comes, all that quiet preparation transforms into motion. The breath becomes a roar. The mountain exhales fire. But for now, in this part of the story, we remain in that waiting space, watching the signs, feeling the slow rhythm of the earth, and knowing that change is on its way. It begins quietly, almost always more quietly than you'd expect. A shiver underfoot, a low rumble in the distance, like a heavy truck rolling far away, except there is no road, and the sound doesn't fade. The air feels different, cooler, perhaps, or maybe it's the stillness, as if even the wind is holding its breath. And then, the mountain exhales. The first sign is not always fire. Sometimes it's a plume of ash, thin and grey, rising straight into the sky. It climbs and climbs until it catches the wind, unfurling into the shape of a spreading tree. Other times, the opening is violent from the start. A deep roar bursts from the crater, and rocks, some the size of houses, arc high into the air. Dust rolls down the slopes in heavy clouds, blurring the edges of the world. From deep within, magma begins its final climb. It is not a smooth journey. It tears at the walls of its conduit, shoving aside fragments of older eruptions, picking up crystals, ash, and gas. When it bursts into the open, it changes instantly. The drop in pressure is sudden. Gases expand explosively, turning liquid fire into a glowing, churning fountain. Lava spills down the slopes, slow enough to watch, but unstoppable. Its surface is a wrinkled skin of cooling rock, cracking to reveal the molten river beneath. Where it moves over soil, it hisses as roots and plants vanish in steam. Where it meets water, it explodes in clouds of white vapor, sending shards of newly hardened rock into the air. The mountain glows from within, its flanks streaked with lines of red. Above, the ash column grows. Fine volcanic dust, sharp as ground glass, rises kilometers into the atmosphere. Mixed with it are droplets of molten rock that freeze mid-air into pumice, light enough to float on water. Lightning flashes within the plume, born from the collision of ash particles, charging the air with sudden, silent light. Daylight dims. The sun turns orange, its edges blurred by the haze. Closer to the summit, the heat is intense. Air shimmers like water over hot stone. The smell is sharp. Sulfur, smoke, the metallic tang of ash. Even at a distance, ash begins to fall. At first, it is a fine mist, almost invisible until it settles on skin. Then it thickens, coating leaves, rooftops, the still surface of ponds. Each flake is a tiny piece of the mountain falling back to earth. Not all eruptions move slowly. Some turn fierce without warning. Pyroclastic flows, avalanches of superheated gas, ash and rock, race down the slopes faster than a person can run. They follow valleys, filling them with a rushing grey cloud that burns everything in its path. From above, they look almost soft, like rolling fog, but within, the temperature is high enough to melt metal. And yet, even in its most violent form, an eruption is not chaos without pattern. Each movement has its rhythm, its cause and effect. A vent opens, pressure drops, lava flows, gas escapes, ash rises. The mountain breathes in great shuddering sighs. Hours may pass, or days. Some eruptions go on for weeks, pulsing between quiet and fury. Others release their strength in a single burst, then fall still. Eventually, the heat lessens, the roar fades. The column of ash thins and drifts apart in the wind. What remains is a mountain changed, its slopes newly carved, its surface dusted with ash, its summit perhaps lowered or reshaped. If you return after the ash settles, the silence is almost startling. The only sounds are the drip of water from leaves, the call of birds returning to inspect the altered ground. The air still smells faintly of smoke and stone. Beneath your feet, the earth is warm. Lava that flowed yesterday may take months to cool completely. Inside, magma still moves, but for now, its voice is quiet again. And so, the moment passes. The sky clears. Plants begin their slow return. The mountain rests, though not forever. The dark chambers beneath remain. The heat remains. The story of fire is never truly finished, only paused, and somewhere below, in the silent pressure of the mantle, the next eruption begins its first patient breath. When the last plume of ash has drifted away, and the final tremor has faded into silence, the mountain stands changed. Its slopes are scarred with black rivers of hardened lava. Its summit is dusted with pale ash, like flour shaken over a still warm loaf of bread. From a distance, it might look lifeless, as if the eruption had swept away not only trees and soil, but the very idea of life itself. And yet, the healing begins almost immediately. The first change is in the air. The sharp, metallic tang of fresh ash slowly softens. Moisture gathers again in the clouds above, washing the fine dust from the sky. Rains return, their drops darkening the pale surface of ash and carrying minerals deeper into the ground. This is no ordinary soil. It is young, born from rock that only days ago was molten. It is rich in nutrients, potassium, phosphorus, magnesium, the very elements that plants need to grow. In a way, the eruption has left behind a gift hidden within its destruction. The first to return are not trees or flowers, but the quiet pioneers, mosses, lichens, and tiny ferns. They do not ask for much. A crack in the lava, a thin layer of damp ash, and they begin their slow work. They cling to bare rock, their roots, or in the case of lichens, their thin filaments, reaching into the smallest grains of dust. Over years, they break down the surface, turning stone into the first fragile soil. Insects arrive next, carried on the wind or drifting down from higher air. Some land by accident, others follow the scent of the new green growth. They find shelter in cracks and crevices, feeding on the moss or on each other. Birds follow, some in search of seeds to eat, others looking for a clear place to rest. They drop more seeds in their droppings, each one a small package of potential. Then come the grasses. Their roots are thin but persistent, slipping between shards of lava and into the ash. Once they take hold, they weave a mat across the ground, helping to hold moisture and prevent the soil from blowing away. With the grasses come the insects that feed on them, and with those insects come predators, spiders, lizards, small mammals. Life, once absent, begins to braid itself back into the land. Years pass. The black lava turns grey, its surface weathered by sun, rain, and frost. Ash-filled valleys host streams again, the water carving channels through the soft ground. Shrubs grow in sheltered spots, their roots anchoring deeper and deeper. Some bear berries, attracting more birds, who in turn spread more seeds. The slopes that once glowed with fire now hold pockets of green. In places where the lava flow was thin, trees return more quickly. Young shoots rise from seeds carried by the wind, or by animals exploring the new terrain. They grow slowly at first, their roots pushing aside fragments of rock in search of deeper soil. Volcanic soil is fertile, but it takes time to hold enough water. Until then, the plants must endure long, dry days between rains. Those that survive grow strong, their trunks twisted by wind, their leaves tough against the sunday. Sometimes, the scars of the eruption never fully disappear. A lava dome may remain bare for centuries, its surface too hard for roots to penetrate. Steep gullies cut by rain may stay raw and open, reminders of the mountain's power. But even these places find their own form of life. Specialized plants adapt to the harsh conditions, and animals use the open ground for nesting or hunting. The land is never truly empty. It simply changes its shape and its inhabitants. Underneath it all, the volcano itself is still alive. Its deep heart remains warm. Hot springs bubble in its shadow. Geysers spray into the cool morning air. These are quiet signs that the mountain's story is ongoing, that what looks healed on the surface is still a place of deep, slow movement within. For the people who live nearby, the return of life is both reassuring and humbling. Fields planted in volcanic soil often yield rich harvests. Forests regrow, providing shade and shelter. Yet the knowledge of what came before, and what could come again, is never far away. In this way, volcanoes teach both resilience and respect. They destroy, yes, but they also renew. They strip the land bare, then offer it the richest foundation for growth. From the day the fire fades, the countdown begins toward the next eruption. It may take decades, centuries, or millennia. In the meantime, the mountain breathes softly, and life returns to dance on its slopes. The scars remain, but they are woven into a new story, a story of moss and grass, of birds and seeds, of rain carving new paths through young soil. The land remembers the fire, but it also remembers how to heal. Far below the surface of the ocean, where sunlight fades into darkness, the world is not as still as it seems. Here, the seafloor is a landscape of ridges and valleys, stretching for thousands of kilometers. It is a place where the Earth's skin is thinner, where cracks open between great plates of rock, and from those cracks, the planet breathes heat. Most of the volcanoes on Earth are not on land. They lie hidden beneath the waves, their peaks unseen, their slopes covered in darkness and pressure. Some are truly asleep, their last eruptions lost in deep time. Others are quietly active, sending out plumes of minerals and warmth into the water. The ocean floor is not smooth. At mid-ocean ridges, two tectonic plates move apart, pulling away from each other at a rate slower than fingernails grow. In the space between, magma rises. It is a slow, patient process. The molten rock meets cold seawater and hardens instantly, forming new crust. Layer by layer, the ocean floor is rebuilt. This is not the explosive drama of a mountain's eruption above the clouds. Here, the work is quiet and constant, a deep hum in the bones of the earth. But sometimes, the quiet breaks. When pressure builds in the chambers below, an undersea volcano can erupt in sudden bursts of fire and steam. The explosion sends clouds of ash and rock into the surrounding water, and columns of bubbles race toward the surface. Most of this remains invisible to us, hidden by depth and distance. Only rarely does such an eruption send enough material upward to breach the waves, briefly creating a new island, a place where the seafloor touches the sky. Some of these newborn islands last only months, washed away by tides and storms. Others remain, their first plants carried by seabirds or drifting seeds. The sea hides other forms of volcanic life too. Hydrothermal vents, sometimes called black smokers, spew water heated far beyond boiling, dark with minerals dissolved from deep rock. Around these vents, life blooms in a way unlike anywhere else on Earth. Tube worms taller than a person, clams the size of dinner plates, and blind crabs cluster in the warmth. They live not from sunlight, but from the chemical energy in the vent's waters, a reminder that life can begin and thrive in places without a single ray of day. Undersea volcanoes also shape the world above. Many chains of islands, Hawaii, the Galapagos, the Azores, are the tips of vast volcanic mountains whose bases rest deep underwater. From the surface, we see only their peaks, while most of their height is hidden beneath the waves. Some of these volcanoes are still active, adding land bit by bit with each eruption. Others have gone quiet, their summits eroded by wind and sea spray, their flanks home to coral reefs and schools of fish. The pressure of the deep changes everything. At depths of thousands of meters, lava flows differently than it does in the open air. It meets water so cold that it chills instantly, forming rounded shapes called pillow lava. Each pillow swells as molten rock pushes inside, then bursts gently as the surface cracks, revealing a fresh, glowing core that hardens again. It is a slow layering, like the growth rings of a tree, but here the rings are of stone, and the tree is a mountain that no sunlight ever touches. Studying these hidden volcanoes is not easy. Scientists send down submersible robots, their lights cutting narrow beams through the black water. The cameras capture ghostly images of vents glowing faintly, lava dripping in slow motion from a crack in the crust, and clouds of tiny creatures drifting in the heated currents. Sound travels well in water, and instruments can sometimes hear an eruption from hundreds of kilometers away, a low rolling boom that moves faster through the sea than through air. These deep volcanoes remind us that the Earth's fire is not confined to the continents. It works everywhere, reshaping the planet in silence and in secret. Even as we sleep, the sea floor grows. Mountains rise and fall. New land is born in darkness, and old land sinks back into the mantle. It is a cycle as endless as the tides, and though these volcanoes are far from us, their work touches our lives. The minerals they release feed microscopic plants, the base of the ocean's food chain. The islands they build become homes for birds and people alike, and the shifting of their plates shapes the very map of the world. The next time you stand at the shore, listening to the waves, remember, beneath that water, the Earth is still breathing fire. Some volcanoes live in a constant state of motion, rising, rumbling, and releasing their heat into the sky. Others seem to vanish into stillness, their slopes green with forests, their craters filled with quiet lakes. At first glance, you might think these volcanoes are gone forever, but the truth is softer and less certain. Volcanoes, like all living things, have lifespans. Some are young and restless, their magma chambers deep and full, their vents ready to open at the slightest pressure. Others are in middle age, still active, but with longer pauses between eruptions. And then there are the ones that sleep. A dormant volcano is one that has not erupted in a long time, perhaps decades, centuries, or even thousands of years, but still holds the possibility of waking. Beneath the calm surface, magma may still move slowly through the deep chambers. It might be gathering in secret, pressing gently against the stone above. From the outside, there is no obvious sign. Villages may grow on its slopes, roads may wind to its summit, tourists may hike its trails without realizing that they are walking on the back of a sleeping giant. Extinct volcanoes, on the other hand, are thought to be finished with their work. Their magma chambers have cooled, their internal pathways sealed shut by solid stone. The heat that wants to find them has slipped away into the mantle. They remain as shapes in the land, gentle hills, sharp ridges, or lonely peaks, but their days of fire are over. Wind, rain, and ice will wear them down over millions of years, until they blend into the surrounding landscape. But telling the difference between dormant and extinct is not always simple. Earth's timescale is vast compared to our own. A volcano that has been quiet for 10,000 years might seem extinct to us, but to the planet, that silence could be nothing more than a pause between breaths. Some volcanoes once believed to be extinct have surprised the world by erupting again. It's a reminder that the line between sleeping and gone is thin and often drawn in pencil, ready to be erased by time. When a volcano sleeps, nature moves in. Forests spread over its flanks, grasses root in its ash. Animals cross its slopes freely, nesting in the shelter of its ridges. In this stage, a volcano can become a cradle for life. Its crater may fill with rainwater, forming a high-altitude lake. The rich volcanic soil supports a wide variety of plants, drawing insects, birds, and mammals. To those who live nearby, it becomes less a source of fear, and more a part of the everyday horizon. Extinct volcanoes often shape the land in gentler ways. Their eroded cones may shelter valleys from wind, creating fertile ground for farming. Their rocky cliffs may form natural barriers, guiding rivers and streams. Some become sacred places, their dramatic shapes inspiring myths and legends, long after their fire has gone out. For geologists, dormant and extinct volcanoes are like history books, written in stone. Layers of ash, lava, and sediment tell the story of past eruptions. Fossilized plants trapped in ancient flows reveal the landscapes that once were. By studying these clues, scientists can better understand not just the volcano itself, but the history of the Earth around it. There is a kind of peace in these silent mountains. They stand as reminders that even the most dramatic forces of nature can grow still. But that peace is not the same as permanence. Under the surface of the planet, the great cycles continue. Plates drift, magma moves, and pressure builds in places we cannot see. When you stand on the slope of a dormant volcano, you are standing in the middle of a story that has not yet ended. When you walk across the flank of an extinct volcano, you are tracing the edges of a story long finished, its ending written in cool stone and quiet air. Both are part of the Earth's memory. Both have shaped the land we live on, and both remind us that the planet's heart beats in rhythms, too slow for a single lifetime to hear. Some giants wake again, others sleep forever, but all leave their mark, and long after the last ember has cooled, their shapes remain on the horizon, in the soil beneath our feet, and in the stories we tell about the fire that once lived inside the Earth. If you could strip away the oceans, peel back the continents, and look deep into the Earth's core, you would find a world in constant motion. Molten rock swirls in vast, slow currents. Heat, born from the planet's creation and fed by the decay of ancient elements, presses outward. It is this inner restlessness that gives us volcanoes. Volcanoes are not accidents. They are a release valve, a way for the Earth to balance the pressure of its own deep heart. Without them, heat would build endlessly beneath the crust, and the surface we know would be very different. They are, in their own fierce way, part of what makes our world livable. Volcanoes build land. When lava cools and hardens, it becomes new rock. Island chains like Hawaii and Iceland exist because of repeated eruptions over hundreds of thousands of years. They enrich the soil. Ash, once weathered and broken down, is full of minerals that plants crave: potassium, phosphorus, trace elements that feed forests and farms. They change the climate, sometimes subtly, sometimes sharply. Large eruptions can send fine ash and sulfur dioxide high into the atmosphere, where it reflects sunlight, cooling the planet for months or years. They also remind us how small we are in the scale of time and power. A single eruption can reshape a coastline, fill a valley, or turn day into night. Yet, from that same force, life returns, green shoots pushing through black rock, birds nesting on new cliffs, people finding ways to live again in the shadow of the mountain. There is beauty, too, in the way volcanoes connect the visible world to the invisible one beneath our feet. Most of the Earth's inner workings are hidden from us. We cannot see the mantle, cannot touch the molten rock that flows hundreds of kilometers below. But when a volcano erupts, the Earth shows us a glimpse of its hidden self, a brief, fiery confession. And volcanoes are storytellers. Their layers of rock are pages in a history that goes back millions of years. They record the rise and fall of ancient seas, the shifting of continents, the dance of the planet's plates. Even a dormant volcano, silent and green with trees, still whispers of the fire that made it. To live near a volcano is to live with this knowledge, that creation and destruction can happen in the same moment. It is to understand that the ground beneath you is not fixed, but alive. We sometimes think of the earth as solid, unchanging, safe beneath our feet, but volcanoes remind us that our planet is, at heart, a restless body of stone and fire. Its surface is thin, its heart is hot, and its stories are still being written. When you next see the outline of a volcanic peak against the sky, whether it is capped in snow, ringed with clouds, or trailing a thin wisp of steam, remember that it is connected to something vast and unseen. Remember that every mountain, every island, every patch of fertile soil owes part of its existence to fire. Volcanoes matter because they are the pulse of the earth. They matter because they are both danger and gift, both ending and beginning. They matter because, without them, the planet would be a quieter place, and perhaps a place without us. And so, the story of volcanoes is not just about fire. It is about the long patience of the earth, about cycles that move too slowly for our eyes to see, about the way life grows again in the wake of destruction. Here, in the quiet after the ash has settled, you can almost hear the mountain resting. You can imagine the deep chambers beneath, holding their warmth in silence. For now, the giant sleeps, but the earth's heart still beats, deep and steady, far below the ground we walk on. As you drift towards sleep tonight, think of that heartbeat, constant, ancient, and part of the same planet, that cradles you in its cool air and quiet night. Good night, from the fiery heart of the earth.